standard deviation. The only difference is here you have wider standard deviation. Here we have lower or narrower standard deviation. That's why the shape of the curve is more wider here, and here it's more narrower. It depending upon how much spread you have around the mean. Here you have more spread, here you have less spread. So if you have less, it will be like this. Again, when we talk about normal distribution, this is what tells us that we are talking about normal distribution, or we are working with normal distribution. The first thing being the mean and second thing being the standard deviation. If we say that we are working with this distribution, that means we are using normal distribution with mean as 20 and standard deviation as 3. When we say standard normal distribution, that means we standardize the normal distribution where your mean is 0 and standard deviation is 1. And how do we standardize? We use standardized score x minus mu over sigma, where mu is your mean, standard deviation is sigma, and x is what we want to standardize. And we will do an example on that. We also talk about empirical rules or 68, 95, 99.7% rule. So when we work with the normal distribution and we need to look either 68, 95 or 99.7% area or the proportion of observations, we use empirical rule. And this rule is applicable only when we work with normal distribution. It is not applicable to any other distribution. So when we say 68%, approximately one standard deviation to the right and left of the mean covers your 68% of the area. So if I'm talking about standard normal distribution where my mean is 0 and my standard deviation is 1, then I'm talking about from here to here, here to here, here to here, I'm moving 1 standard deviation. So if I look from here to here, I'm talking about 100% of the observations or 100% area from the both ends. When we say 100% normal distribution symmetric, if I divide it into 2 equal halves, this part is 50% and this is also 50%. So I'm dividing into 2 equal halves, 50-50%. Now when I'm talking about 68%, I'm moving to 1 standard deviation to the left and right of the mean. So I'm moving 1 here and 1 here. And this covers my 68% of the observations or 68% area. So when I'm saying 68%, and since it's symmetric distribution, they are both 34%. And we covered this topic in the last class, but I just want to make sure that you understand it clearly. So going over again, and if you have any questions, feel free to ask. So this is when we talk about 68%, and it's mentioned here, observations fall within 1 standard deviation of the mean, 95% within 2 standard deviations. So we are moving 1 more and 1 more. So we are technically talking about this part. So this is my 95%. If this is 95%, that means if I go either left or right, it is half of 95, which is 47.5%. And I know this part is 34, and this whole is 47.5. And when I subtract 34 from here, this will be 13.5%. And same thing you can say here, because it's a symmetric curve. If you know one, you can find the other. When we talk about 99.7, we are moving to 3 standard deviations around the mean. So this is my 99.7%. And this part is half of 99.7, which is 49.85%. And again, when you subtract 47.5, you will get this part, which is 2.35%. Same thing, we get 2.35%. So right now, up till here, we talk about 99.7. But from here to here, it's 100%. This whole thing is 100%. So we calculate up till here, it's 99.7%. What about the edges or the corners on the 3 standard deviation above and 3 standard deviation below? So it is the remaining from 99.7%, which is 0.3. And 0.3 is the sum of this and this. So we divide 0.3 into 2. So this will be half of that, which is 0.15%. And when you add all these percentages, they will add up to 1 whole or 100%. Again, 68, 95, 99.7 rule talks about only these three, 68, 95, 99.7. It helps us to look at the area. Let's say I want to see how much is the area between -2 to +3. So I can see how much here, 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 here by using this information and add and do it. If you look at start 1 weight notes and you go to the last one, you can see here there is an example solved, and if you just look at the top part, this is what we just exactly did. How much is the area in each particular standard deviation to the right and left of the mean. And when you add everything, this will be 100% or 1 whole. And this question also says that instead of mean 0 and standard deviation 1, we are talking about mean as 336 and standard deviation as 3. So you take mean as 336, and then you keep on moving 3 standard deviation, then it will be 339, then add 3, then add 3. Same thing, subtract 3, subtract 3, subtract 3, and you will get that. And it's also asking find the range of length of 4 pregnancies which cover 95%. So when we are saying 95%, 95% is within 2 standard deviations. So this is my center. So I'm moving 2 standard deviations to the right, 1, 2. So this is my upper down and 2 standard deviations to the left. So when it's asking you the range, so it's asking you what's your lower value, what's your higher, or the minimum or maximum. That's how we calculate the range. So it will be from 330 to 342. Same thing, if I ask how much is the area between 329 to 342, can we find that? 329 to 342. Then I will just look at this, add everything. Or I know that from here to here it's 95, and then I add this. Or you can do that if you are looking at this particular range. If I am looking between 329 to 342, I can look at the area to the left and area to the right of this. I can add these two and subtract from 1. I can do that way, or I can just look at these and add. So either way is fine. You know that the total is 100 or 1 whole. So if you are looking for 100%, use percentages. If you are using 1 whole, then convert it into decimal and then work with that. So read the question. If the question is asking you to give the answer in percentages, then use percentage. If it's not, if it's asking you in the proportion, and then you can convert it to decimal and work with that. Take a look at this example, and if you have any questions, let me know. So this is what we did earlier. 68, 95, 99.7% rule. Remember that you can apply this rule only when the distribution is normal. When it's not normal, you cannot work with this rule. So the same kind of example is solved here. Make sure take a look at that and let me know if you have any questions. Standardizing observations. So we, as I discussed, that we do standardize observations when we are looking at when we need to compare 2 different observations on the same scale, but they are not actually on the same scale. So the easiest example is SAT score and ACT score They both, when students apply for college admissions look for either SAT score or ACT score. But we know that SAT score is from 1600 and ACT is from 36. So if somebody got 35 out of 36 and 1520 out of 1600, do they just divide it and look at the percentage? No, they standardize it and then they bring it on the same scale and then compare it. So when we need to compare two different, when we have to compare two units, but they are on different scales, then we standardize it so that we can easily compare it. And that standardizing, when we standardize it, we say that z-score or standardizing score. So standardizing observations, if a variable has x distribution with mean mu and standard deviation sigma, then the standardizing value, z-score, we also call it a standardized score. Then we work with z-score. And again, when we are working with z-score, we know our mean and we know our standard deviation. Mu and sigma is given to us. And if I am standardizing x, I need to know what is the value of my x. Once I get this z value or standardized value, then I will use table A. And we will talk about how to see table A. Then we will use table A to find the area under the curve or the probability. So when we are looking for standardized score, first of all, we need to know what's my mu and sigma. So if it's given as standard normal, I know my mean is 0 and standard deviation is sigma. If the question just says that we are working with standard normal, we just go with 0 and 1. And if it's not, then definitely we will have some mean and standard deviation. So here my mean is 10, standard deviation is 3, and if my x value is, let's say, 12, then I can find my z as 12 minus 10 over 3, and then I can calculate that. And once I get that z value, I will go to the table and look at the corresponding z value. This is one way to do the standardized value problems. The other way is you can use your calculator also to find the area under the curve. You can use any software also. But again, when you are taking a test, so either you can use the table or use the calculator. Again, once you understand how to use the calculator, it's fast and easy. And we don't use tables in our day-to-day life to look at the standardized value and then find the area under the curve. But it's always good to know the logic behind where is it coming from or what is the reason to do this part. So when we are talking about standardized score, again, as I mentioned, we also talk about standard normal distribution. Standard normal distribution, it means 0 and standard deviation 1. In some problems, you will see that the question just specified that we are working with the standard normal distribution, find the corresponding z if x is this, and no mean and standard deviation is given. If no mean and standard deviation is given, make sure read it. Is it a standard normal distribution? If it says standard normal, then we know that 0 is the mean and standard deviation is the 1. If it's given or not, we know that standard normal distribution where mean is at the center and that center is 0. And we are moving one standard deviation to the right and left of the mean. So 0, 1, standard normal. Otherwise, it's normal, whatever mean and standard deviation you have. So this is table A, and this table is also uploaded on your Canvas, as well as you can find this table on chapter Stat 108, chapter 1C notes. And it is in your book also. If you go on your ebook, you can find that, or otherwise go on the Launchpad and look at the table. You'll find it there as well. Because all normal distributions are same, when we standardize, we can find area under any normal curve from a single table. So since all normal distribution will be same when you standardize because it's 0 and 1, so we can find the area using one single table, which is called your table A. Table A is also called as standard normal table or standardized table. Table A is the table of area under the standard normal curve. So if you are looking for standard normal, you are using table A. You are not using table A for any other distribution. The table entry for each value of Z, which is our standardized score, is the area under the curve to the left of the Z. So this thing we need to write. You guys can write this on your notes that the table A gives us only the area to the left of your standardized score. So if this is my standard normal, and if I'm looking at Z, this table is giving me only to the left sided area. Same thing. If this is Z, it is giving me only the left sided area. So if the table is giving me only the left sided area, how do I find my right sided area? Any thoughts? Any idea? Any guesses? So if I'm using the table gives me the left sided area, either here or here. But if I'm looking for this one, table does not give me that right sided area. How do I find that? I know that. Yes, go ahead. You are subtracting from 100. You are subtracting from 100 or one whole. Perfect. We know that the area under the curve is one whole or 100%. If you find the left-sided area, you know that this whole thing is 1 or 100, depending upon if you are using the area in decimals or in percentages. Then subtract from 1, you get the right-sided area. Or you know that this is a symmetric distribution. If this is a symmetric distribution, whatever the area here, I will have the same area here, right? If I'm looking at the left of Z here, whatever value I have here, if I'm looking on the right side, it is exactly the same. So if I'm looking for the right-sided area of this, then what I do, I can look at the opposite sign, and which I will tell you when we will use the table. So I will just read the problem from here, and then I will show you the table. Suppose we want to find the proportion of observations from the standard normal distribution that are less than 0.81. So if we are looking for less than 0.81, if we are looking for this box, how do we use the table? So let me go back to the table, and this is table A. Some places you find the table, you have negative values here and positive here, but here you will see negative on one page and positive on one page, but it's talk about the same thing. So if we look at this first thing, this is the standard normal probability, the standard normal area, and table entry Z is the area under the standard normal curve to the left of Z. Always remember that part. This table, when we are using table A, it is giving us the left-sided area or left-sided probability. When we use the calculator, that is not the case. So remember, if you are using the table, use the table. If you are using the calculator, do that. Do not mix both. Do not use calculator for half of the problem and table for the rest half. Either use calculator or use table, because table only gives us the left-sided area. To find the right-sided area, you have two options. Either you look at the opposite Z score. So if your Z is 0.81 and you are looking for the left of that, and you need to find the right, find this value, subtract from 1, you get it, or look for the negative 0.81. And let's do an example first so that it will make more sense. So look at the table first. The first thing that you see is Z or standardized score. And on the right side, you see 0.00, 0.01, 0.02, and keep on going up till 0.9. And if we go under this column, you start from negative 3.4 and look at the first value, 0.0003. And this value is very, very close to 0. And from here, the value keep on increasing, and keep on going. And the last value that we see is 0.9998, which is very, very close to 1. So we are talking about between 0 and 1. And again, we are using standard normal table. So it is between 0 and 1. So if I'm taking the maximum as 3.4, if I'm going after 3.4, 3.5, then that means it's more than, it's 1. And here it's less than 0. So if we are starting from here, the first thing when we have to look at the z value is this. So I'm looking for, let's say, z less than 3.25. Let's say just look at this number. If we are looking at the value of z less than minus 3.25. So first thing I need to do is have a look at this part in the table. So I'll go to this one. If I go here, not this, this is the one that I am looking for. The next is 0.05, right? After decimal, I look at negative 3.2 and what's left is 0.05. So 0.05 is not this, so this one. So I'm looking for this column and I'm looking for this row. And where they both intersect, that is my value of z less than negative 3.25. Questions? And again, this z less than negative 3.25 is the left-sided value. If I am asking what is the value of z greater than negative 3.25, you already calculated this part. Subtract this from 1 and you get the value, because when you add this plus this, it should add up to 1 whole or 100%. It's in decimal, so when you want to give the answer in percentages, multiply it with 100 and then you get it in percentage. So if you are looking for the greater one, whatever your value is, subtract from 1, you get this. Questions up to this point. How to find the z value from the table. So the table provides us the left-sided value. Find the left-sided value. If you want the right-sided, subtract from 1. This is one way to do it. Second way is, you're looking for greater than negative 3.25. So go to positive 3.25. So this is your positive 3.25, right? 3.2. So I will just go this way. And 1, 2. So this is my fifth one. If I look at the table, this is my 0.05, right? And where are they intersecting? They are intersecting here. So this is the value for z greater than negative 3.5 is 0.994. And can I check my answer, what I got it here? Is it the same? Can I subtract? When I subtract this, can anybody tell me what will be the value here? When I subtract 0.0006 from 1? 0.9994. And is it the same value that we get in the table? Yes. So you can do it two ways, whichever makes more sense to you. If you are looking for the greater value of negative or positive, go on the opposite sign. And if you don't want to do that, you can just subtract from 1 and that way will work too. Questions? Okay, so let's do the example from the slide. So same thing here, it's saying that z less than 0.81. You go to the table, you look at the 0.8 and 0.1 and where they intersect is this. And if I'm looking for the value of z greater than 0.81, can you guys tell me what value will that be? Looking at the information on the screen? Or how can we find that? We know the value. Perfect. 1 minus the value and you will get that. Or look for negative 0.81 value in the table. So let's go to the table. Negative 0.8, which is here, and this is 1. So if you subtract 0.7190, you will get this value. So either way, whichever works, you can do that way. So that's how you find the standardized score value if you know what Z is. And if you do not know what Z is, first you need to solve for Z. And that is again, you will use this formula to solve Z. So let's do an example how to solve for Z. And again, I am going back and forth so that I can cover most of the part. And you have these examples in your Stat 108 notes. And we will also talk about how to use calculator to find the similar, instead of using the table for the similar problems. So before that, let me see. So let's talk about one of the problems. First, if I have to find Z, if Z is not given to me straightforward, I have to find Z, and then I will do what I have just done, looking at the table, find the corresponding value. So I'm taking an example here. In a study of exercise, a large group of runners walk on a treadmill for 6 minutes. Their heart rates in beats per minute at the end vary from runner to runner according to mean. And again, if this part is given, I know that I'm talking about a normal distribution. And the first thing is my mean, and second thing is my standard deviation. So you have mean, you have standard deviation. Now the question is asking you, find Z score for 120 beats per minute for a runner. So now Z score is not given. You have to find the Z score, but you have sufficient information to find the Z score. Your X is 120 because that's what you are looking for. Your mean is given to you in the question, 104. And your standard deviation is also given to you as 12.5. So use this information and you can find the corresponding Z. Once you find the corresponding Z, if you're looking at the area under the curve, go to the table, find the corresponding value for 1.28, and then you are done. Questions, how to solve for Z. There are a lot of examples out here, so I suggest you to go and take a look at those. If you have questions, okay, if not, so let's do this example together. And if you have calculator, we will talk about how to use the calculator also. So find the proportion of observation of the standard normal distribution that are between this range. First of all, tell me if this information is given to me standard normal. They don't give me mean and standard deviation. Can I still solve this?
Yes.
Yeah. So what should be my mean?
0.
0 and standard deviation 1. So if you don't have mean and standard deviation, but you have the information, what should be your mean and standard deviation when we talk about standard normal distribution? So when you're talking about standard normal distribution, you have this information. I cannot connect everything just like that. So first thing, I will make a density curve and represent everything there. So this is my mean, 0. And then I'm talking about 1 standard deviation to the left and right of the mean. Right? That is my standard normal. Now the question is asking me find the proportion of observation. Again, we are looking for standard normal between these two. Negative 1.25 will be between negative 1 and negative 2. So let me draw it here. And let's write it negative 1.25. So I'm looking for between this and 0.8. 0.8 will be somewhere here. 0.8. So the question is asking me to find this part, this shaded part. Find the proportion of observation from the standard normal between this. Now, when I use the table does not give me this specific area. If I'm using the table, let's say this is my 1.25, table will give me this. say this is my 0.81, this. Table will give me this and this, but table will not give me this part. How do I find? So let's look at left of negative 1.25. Can I find that part from the table? Yes, we can find this part using the table. So let's quickly go to the table and look for left of negative 1.25. This is your negative 1.2 and this is your negative 1.25. Everybody agree? So it's 0.1056. So let's write. So I get this part. And then I use left of 0.81. That means I'm talking about this whole thing, right? The table will give me this, and we just calculated in the previous problem. It is 0.7910, right? So that means I'm counting this part twice. I looked at this when I was looking at the left of this, and I included this part when I looked at this too. So if I remove or if I subtract this area from this whole, it will give me this part, right? If I subtract this yellow one, highlighted area from the left of 0.81, I will left with only this part, right? So subtract this from here and you will get the answer. 0.7910 minus 0.1056. And they did it another way. So they looked at the left-sided area of this, right-sided area of this, subtract everything from one, and then you get this. So you can do either way. And let's talk about how to use calculator to solve this. Anybody has any questions? And again, this is a very important topic. So if you have any questions, if you think I'm going too fast, too slow, just let me know.
I have a quick question. So for the yellow area in the curve, why did you pick the value at the negative 1.2 as opposed to finding some value between the negative 1.2 and negative 1.3 on the table?
So I look at negative 1.25. So if I'm looking at the table for negative 1.25 in the table, so Z has up to two values after the decimal one, right? And then the remaining part is this left. So if we go to the table, you see there is only one decimal. There is only one digit after the decimal. So if I'm looking for negative 1.2, I don't have 5, but I know that if I go on the top of the table is 0.00.0, so I'm looking for 0.05.
Okay, thank you.
You're welcome. Any other questions? All right. If not, so let's do an example using the calculator. And if you have calculator, you can use that too. So let's use the same example so that we can match our answers. So if I'm looking for standard normal, and then I'm looking for 0.81 and finding this. If I'm finding this area, and again, I don't have access to the table, I cannot use the technology, but I have calculator to solve this. And my curve looks weird, so do not worry about that. Think of that as a symmetric distribution. We are talking about normal, and I'm looking for this value. So when you use the calculator, if you have the calculator, you go to seconds and then variables, or you have some of you might have distribution. If you go on that, you will see you get some options. The first one says normal PDF, and the second one says normal PDF. And what is the difference between PDF and CDF? So when we say PDF, we call it probability distribution function, and CDF is the cumulative distribution function. And here we are talking about the cumulative from here to here. We are not just talking about specific one. So we will go to the normal CDF part. Normal CDF, cumulative distribution function. And when you hit on, when you hit on this or enter this normal CDF, it will ask you a few things on your screen. It says lower, upper, mean, and standard deviation. And if you don't see that, no problem. That means you have to do your diagnostic on. And when you do your diagnostic on, it will ask you, if you go on the bottom catalog and you hit the catalog and it will say diagnostic on, and then you do diagnostic on, then you can see. And if still you don't see that, you will see a parenthesis. So you have to enter 4 values here. The first one should be lower, then upper, then mean, and standard deviation. When we are talking about mean and standard deviation, definitely we know what is our mean and standard deviation. In this case, our mean is 0 and standard deviation is 1. The only issue is what is lower and upper. So think about that. You are looking for the area under the curve. So when you look at the area, you should have some range, right? You should have a lower and upper bound. What area you are looking for? So if you're looking for the area for up to 0.81, so that means 0.81 is my maximum. I am looking up to 0.81. So that is my maximum value. What should be my minimum? So minimum should be, if I go on the left of this, right? So I'm going here, 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 here. What do you think will be my minimum? Where will I stop? I'll just keep on going up to negative infinity, right? I'm going in left direction. So the minimum value should be negative infinity. So in your calculator, you can add 9999. I think bunch of 9, 4 or 5 9s. So this is your lower, this is upper. Upper means the max value that you are looking for, and mean and standard deviation. And when you hit enter, you will get that value. If somebody is using the calculator, can you tell me what answer you get?
I wasn't able to get to the lower upper. It's just showing normal CDF and then
okay. So we'll do this. And
I got
then hit enter. So if you do the first is lower, upper, 0 and 1, you can do that and then close the parenthesis and hit enter. Somebody got the answer?
negative 0.2089 and a bunch of other numbers.
No, is that you when you use this thing? That's what you got?
I got 999 be negative.
Oh yes, yes. Sorry. Yes, it will be negative. Thank you.
So there I got 0.79. Yeah.
Okay, yeah. Sorry about that. Yes, because we are talking about negative infinity, so you are going on the negative direction. So negative 999.810 and 1. So when we are talking about, and when you do for positive 99.81, it's not even going to work because we start from infinity and maximum is 0.81. It's not going to work because maximum should be infinity. So 0.79, and if you look at the value that we were using here, we got this value. And again, when you use the table, your values are little different in the sense they are little different by the decimal, like 0.0001 or 0.003, because calculator gives you the exact value. In the tables, we are using the approximate value, but they will be close. So that's how we use the calculator. So this is when you are looking for left. Let's see if I'm looking for the right of. If I'm looking for right of 1.81, one way is you find the left, subtract from 1. But if you are using the calculator, you don't have to do that part. Why you find the left, subtract from 1, and then you get straightforward the value on the right side. So if I'm looking for this part, tell me what should be my lower, what should be my upper. Mean and standard deviation is given to us. What do you think the lower should be?
0.81.
Right, because we start from here. So your lower and upper will keep on changing depending upon what you are looking for. And mean and standard deviation remains the same if you are working with standard normal or if you are working with some other values for the normal distribution, let's say 10 and 3 or whatever your value is. What should be my upper? Where is this going?
999.
Infinity, perfect. And then you can find that value. So calculator, you don't have to subtract from 1. But in table, you have to subtract from 1 to get the right-sided area. And let's do one more example that we just did, this one. If we are looking between negative 1.5 to 5 and 0.81. Let's do this one also, so that you know how to do it using the table or the calculator. So if we are looking for in between this. Yes, lower, upper, mean, and standard deviation. What do you think will be the lower here?
Negative 1.25.
Perfect. Negative 1.25. Upper is your 0.81. And you will get it. So you don't have to go through the table, subtract it, find the area to the left of both, subtract it, and then find it. Plug these numbers and you will get it. So it's totally up to you. If you want to use the table, you want to use the calculator, but my suggestion is one problem if you're working on, do not use both. Either use calculator or table because they both are used differently when you are looking for the right-sided area. Or in between. Yes.
What was the criteria for using the normal PDF?
So normal PDF, when you are looking for the individual probability, then we use normal PDF. And we will talk about this also.
Okay.
So when PDF is the probability distribution function, and again when we are talking about CDF, we are taking the cumulative or the combined. Like here we are looking for this one. Right?
Yeah.
So that's
okay.
All right. So the last topic for this one, and then we have one more, uniform distribution. So when we are talking about normal calculations, so far we know we have our z-score, and then we look at the corresponding area. What happens if you have the area and you are finding the corresponding z or the value of x? So we just worked on this. First find the z value, and then we find the corresponding z values area. Now what happens if we have the area? Area is given to us, but we need to either find the corresponding z or the corresponding x. So can we find that too? Yes, we can find that too. Now we are doing the opposite for what we have just done. To find the area, we were looking for lower and upper, right? But if area is given, I don't have to look for lower and upper. I can just plug the area, and then I need to know my mean and standard deviation. It's even simpler. But the thing is, do I need to use the table or calculator? Again, the answer is yes, you can use both. So first thing, if you are using the table, if the area is given, let's use the same example. How tall a man is a man who is taller than exactly 10% of the man aged 18 to 24. So if it says how tall a man who is taller than exactly 10%, so you have the area. So once you have the area, you need to find the corresponding z-score. And how to find the corresponding z-score? If we look at the z-table, the z-table gives us the values in 4 decimal places. So I will go to my table and find this value in the table and find the corresponding z. I may not find exact this value in the table, but I will be able to find something closer to this. And this is 0.10. So again, I know that when I'm talking about normal tables, the table starts from here. It starts from 0. So it starts from 0 and I'm looking for 0.1. It's 0.0. So it will be somewhere in the negative. So if I look here, this is 0.0. I will keep on going until we get 0.1. So if I will keep on going 0.0, 0.0, I will get 0.1 here. So I'll go on the top and I will look at here. Look at this one. This is 0.0985 and this is 0.103. So these are the two close values and my 0.1000 lies between these two values. Agree? So if this lies between these two. Should I go with this or should I go with this? Again, when you are working with the table, you need to pick one. You cannot pick two corresponding z-scores. So look for whichever is closer to your value. If I look at this one, this is 0.0005 less. And if I look at this one, this is 0.0003 more. So this one is closer, right? So you need to look for whichever is closer. So if this is closer, I will go to the corresponding row and column to see what my z-score value is. And now I can write my z. What will be my z? First I will write these two things, negative 1.2, and then I will look for this, which is 0.08. This will be negative 1.28. So this is the way how you can find your corresponding z values using the calculator, using the table. Questions? And again, I'm saying that tables are approximate. When you work with the calculator, it will give you the exact value. So let's go back to your question. This is how, and in the slide also, they showed you how to find the corresponding z value. So once you find the z value, now the question is asking you how tall. So you are looking for the value of x. So you formalize x is this, right? So we are looking for this. We can manipulate this formula a little bit to solve for x, right? X z times sigma plus mu gives me the value of x. I calculated my z, negative 1.28. I know my sigma, I know my mu. I will plug these values. So it is given to you in the question. Mean is 70 and standard deviation is 2.8. Plug these values and you can find your corresponding x value. How to use the calculator? I do not have much time here, but let me just quickly show it to you guys. If you look at Stat 108 notes, you will find the instructions how to use the calculator for finding here. So it's called inverse normal. So the second one you did when you look for the normal CDF, your second option was normal CDF. Third one is inverse normal. When you go to inverse normal, it will ask you area, mean, and standard deviation. So area is your 10%, your mean was 70, and your standard deviation was 2.8. You hit enter and you will get the same answer. So you can use and think about that why we are saying inverse normal. We are doing that inverse for what we just have done. So we did normal CDF using lower, upper, mean, and standard deviation. Now instead of lower and upper, my area is given to me. The only thing that you need to remember when you use the calculator is the calculator, you always need to write the area to the left. You always need to mention area to the left. Let's say instead of 10%, the question gives me that this is 20%. And how tall is that? And I'm using the same thing. And I am looking for the right-sided area. So if I put this point to 0, I will get the wrong answer. So first thing, find the left-sided area, which is 80%, and plug that value to solve. So this is the thing that you need to remember when you are using the calculator for inverse normal. Always write the area to the left. Even if you are looking at the right-sided area is given, let's find what's your left-sided area. And you have questions like this in your homework assignment, like what we just did. In normal quantile plots, again, we make quantile plots, and you do not get tested on that because it's hard to make quantile plots manually. You use some kind of software to work on that. The last topic that we need to cover is uniform distribution, and this is not in the slide, so I want to make sure that I will explain that part in the next class so that's why your homework and quizzes moot. But if you want, you can go ahead and attempt one or two homework assignments. Uniform distribution is a rectangle distribution, and we use the same concept length and width, but it is not in this form. So I guess I'm past time. I will stop here and wishing you guys a great weekend. And I'll see you guys on Monday. And we will be finishing on Monday. You're welcome.
Goodbye.
What the fuck? Goodbye. Oh, stop recording.